Hi, this is Meganadha. In this module, we will learn operators in C language. Now, before we jump into this topic on operators, I'll write a simple program so that you will understand what is the importance of operators in C. So let me open code blocks and file, new, empty file. And remember, this is module number 6. Now what I'll do is, let me expand this and I'll save it now. Now I'll just write here 6.learn operators.c. Now before we jump to the topic of operators, I'll write a simple program to add two numbers. Include stdio.h, include conio.h, which we already know it. So I'll write here void main, and then we normally use to write int a comma b, and we can read the value from the user, enter first number, and then we can write scanf. We know it already. Scanf %d format specifier comma ampersand a, and then printf, enter second number, and then we can write here scanf %d. So in double quotes we have to put %ld and comma ampersand b. Now what we need is we need to write C. Let's declare C, and I'll write here C is equal to a plus b, and then we write printf sum is equal to %ld comma C. Now we are done with the program, and last we used to write get ch. So anyway, that now we have written a simple C program for declaring three variables, and we are reading the first number, we are reading the second number, and here we are adding two numbers and storing the result in C, and we are printing the result. Now this plus is an operator that adds two numbers, and now let me open Notepad. So what is the word that we wrote here, the sentence C is equal to a plus b? Now let's try to understand more on this. Now I just increased the font size. Now see here, this symbol plus is called operator, which is used to add two numbers. Similarly, we have so many operators in C language which will perform different operations between two operands. So in this case, we call a comma b are called as operands, and C and plus is called operator. Now let's try to understand this. So for just addition of two numbers, we are using the operator plus. For multiplication, we would have written like this, and for division we would have written like this. So in C language we have many operators like this which will perform different operations between two operands. So these are called operators in C language, and these two are called operands. Now we have so many operators in C language that we categorize them into different types. So now let's try to understand one by one category of operators, and we'll also understand how we can use that operator in C language. Now let's get started. I prepared a small presentation for that, so let me open the presentation and let's try to understand. So here you can see that, let me zoom this, you can see here arithmetic operators, basic arithmetic operations we can perform, like addition, multiplication, subtraction, multiplication, division, and this is called modulo division. So don't get confused between division and modulo division. I'll ensure that you're clear with that. Now let's try to understand the first one, arithmetic operators, in the next slide. So as usual, 6 plus 3 is 9, 6 minus 3 subtraction operator, and 6 star 3 18, and division operator and modulo division. Now a lot of times I see some confusion among the students between the division operator and modulo division. So remember, division actually divides the two numbers and gets the value. So we can cancel this, 3 2s are 6, and that's the answer. That's for normal division. Whereas modulo division will give the remainder. Now let's see the example. Now you can see here, so 5 divided by 2, because it's integer, it's rounding off to 2, and 12 by 2, it's 6, And ideally this is actually you can consider this as 2.5, right? And 5.0 divided by 2.0 is 2.5. So this, all these things that we have seen here is a normal division. So that's a division operator. And the next one we have is modulo division. So what is this modulo division operator is, so you have to divide the first number with the second one. So now I'm dividing it. Now 5 2s are 10, and you'll get the remainder as 2. So this remainder is called the answer. So modulo division will give the remainder. So now you can see here, so I'm dividing with second number 5, 5 2s are 10, 2, answer. Modulo division will return the remainder. Now you might get a question here, 11 modulo 12. Remember, the question is not 12 modulo 11. If I would have asked you 12 modulo 11, the answer is simple. It is 1. So what you do now, you'll divide with the second number, and always you have to divide with the second number. So 11 ones are 11, and the remainder is 1. So this answer. But the question is not 12 modulo 11. The question is 11 modulo 12. So now, as usual, you have to divide with second number, and here 11. So it not even goes once. So 12 ones are 12. So you have to write here 12 zeros are 0, and the remainder is 11. So this is the answer. So now you can see here, so answer is 11. So when numerator is smaller than denominator, modulo division will return numerator itself. So this is called numerator, and this is called denominator. Now when the first number is smaller than second number, the answer for modulo division is the first number itself. Like 2 modulo 3, the answer is 2. 7 modulo 9, the answer is 7. Same way, 11 modulo 12, the answer is 11. Now we are clear with modulo division. Now relational operators. Now as the name itself is suggesting, relational operators will tell the relation between two operands. So we'll be using equals to in if condition. So in C language or any programming language, when you write a is equal to 5, this is for assigning the value 5 to a. When you write b is equal to 10, that's assigning value 10 to b. So this is called assignment operator. But the double equals to is used to check if both are equal or not. So that's why, so relational operator, here we are checking whether these two are equal or not. This is not equal to 5, not equal to 3, 5 greater than 3, 3 less than 5, 5 greater than or equal to 5, 9 less than or equal to 12. So in all these scenarios, we are checking the relation between two operands, whether they're not equal, equal, greater than, less than. So that's why these are considered as relational operators. The first one being is used to check for equality, not equal, greater than, less than, greater than or equal to, less than or equal to. So all these operators belongs to relational operators. Okay, so we just completed arithmetic operators, and we also completed relational operators. The next thing is, let's see. So we have logical operators. So logical operators are normally used in writing some logic. And let's take, for example, you are writing a software for a retail company. Let's take you're writing a software for Walmart. Or in that case, you need to provide a discount. Like if the product type is apparel, and the product quantity, if the user is buying, quantity is greater than or equal to 3, so you want to provide a 30% discount. So for product type is apparel and quantity is greater than 3 or equal to 3, you want to provide 30% discount. So in this case, you have to write a condition like this: if product type is equal to apparel and quantity is greater than or equal to 3. So that means you're writing condition. So you are writing a logic. So that's why this is called logical AND. Now you can see here we have logical AND, logical OR. So the OR is just near the pipe symbol, which is located in your keyboard near the slash. Right, so this is a pipe symbol, so this is that's OR symbol. Let me type it in Notepad so that you will be clear. Now see here, this is logical AND, and logical and, sorry, let me type it once again, logical and, logical or, and logical not. So these are the three symbols that you have to know. This is used for AND condition, this is used for OR condition, and this is used for NOT condition, right? So I'll just show you once again where is this pipe symbol. So what I'll do now is, so I'll just search for keyboard so that I can see, I can exactly show you what is the symbol is, right? Let's say this. I just searched for keyboard image in Google Chrome, and I just want to show you that what's the symbol that here. This is the symbol that we are using for logical OR. Two symbols like this. So that's the symbol we are using for logical OR. Two times we are using that, right? Let's come back. So this is logical OR, and now those are called logical operators. And the next thing that we don't want to discuss in depth about it for now, maybe later sections we'll understand when we do some programs, right? So let's see the next one, bitwise operators. So to understand bitwise operators very clearly, you should know how to convert binary normal decimal number to binary number and binary number to decimal number. So again, this is something which is beyond the scope of this course, but let's try to explain in a calculator, right? Let's see this. I'm not going to explain how this actually is done for now. So let's say this. Let me open calculator in Windows computer, click on start, calculator. Now normally when Windows 10 or an operating system, when you open a calculator, you will see the standard calculator. So let me open programmer calculator. And now I want to find 6 and 3. So bitwise AND. So I'll type here 6. You can see here AND. You can see here AND 3. Now I'll write equal to. Now you can see here 6 and 3 is 2. The same thing is here. And 6 or 3. Now let's try once again 6 or 3 is equal to. You can see that 7. Now this is called exclusive OR. 6 XOR 3. 6 XOR 3 is equal to. You can see this as 5. So there is some typing mistake here. It's actually 5. And you can see here the answer is 5 here. Now let's try to do this programmatically. So I'll show you with a simple program. Now as usual, I'll just remove this. You can see here, let me remove this code. I'm writing here int a is equal to 6, b is equal to 3. Now printf, I'm writing here %d. First we want to print a and b. In case of %d, it'll print a and b. Now printf %d comma a or b. So this, remember, don't get confused with logical and bitwise and. This bitwise and, this bitwise or. Now I'll write here printf %d comma a XOR b. Now that is an exclusive OR. Now let's run the code and let's see the output now. So before that, I'll just write here and value, and I'll just write here exactly what we need. So %d and %d is equal to %d, so a comma b. So in this case 6 and 3, that will be the answer in the last %d. Now I'll just copy paste it now, Control C, and this is for OR, this is for XOR. So now I'll write here OR, and I'll type here XOR, and here I need an OR operator, and I need a XOR, exclusive OR. Now we're done. So I'll just add here /n so that I'll see the output in the new line. So let's put /n and /n and again /n. Now let's save it and let's run the code, build it, and now you can see that there are no errors, and run the code. You can see we got the same output that what we got in the calculator. So you can see here, and we are just converting 6 and 3 as 2, and you can see in the same slides as well. So 2, 7 and 5. So we got the answer programmatically. Okay. Now, where do we use this AND, OR, and XOR? Is normally in embedded systems or robotics technologies or animations. We use these operators, but in normal traditional programming for web applications or programming for domains, we don't really use this bitwise operators, right? Now, shift operators. Again, shift operators is again beyond the scope of this course, but still, let me explain this for you. So all you have to do is you need to convert the first number to binary. So 6, when you convert to binary, you'll get 110, and you need to move this left side 2 times. So that you need to add 2 zeros. So left side 2 times and add 2 zeros and convert this to decimal. You'll get 24. So I repeat once again. So convert the number to binary and move towards 2 times or 3 times, whatever is mentioned at the second operand, and add zeros and convert the total to decimal. Now coming to right shift. So convert the first number to binary and remove the right side 2 digits, whatever you have, and convert again to decimal, so you'll get the answer. Now let's try to do this. Let me explain you now. Let me open MS Paint. Let's try to understand this. So let's take, I want to find 5, left shift 2. What I have to do now? 5 convert to binary. So how do we convert 5 to binary? So 2 to the 4. 2 to the 4. Remainder is 1. Sorry, let's do it once again, right? So let me delete this. I'll make things very clear for you. Now I'll just write it here too. So let's select this. We need to always to convert a decimal to binary, we need to start with dividing with 2. Right now 5 and 2 2s are 4, remainder is 1. Again divide with 2, 2 1s are 2, remainder is 0. You have to write in the reverse order. So 101. So 101 is the binary format, and left shift 2. So what you have to do is you need to push this side and add 2 zeros here. So it will become 1010, 0, 2 zeros. Now you need to convert this to decimal. So how to convert this to decimal? So 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. Or you can simply, so 101, so 2, 0, this 0, this 0, and 2 square into 1 is 4, and this 0, 2 power 4, 16, 16 plus 4, 20 is the answer. So 5 left shift 2, the answer is 20. Let's do it programmatically. Now what I'll do now is printf /n 5 left shifted 2 is equal to %d. Now in case of this %d, I want to print 5 left shift 2. Let's see if it prints or not. So we are expecting 20 in this line, 4th line. Let's save this and build it. So no errors. Let's run the code. So you can see here 5 left shift 2, we got the answer is 20. Now the right shift. So let's try to learn the right shift, or we'll see one more example for left shift. Okay, so let's see this. Now I want to learn about 3 left shift 3. So all you have to do is convert this 3 to binary. So 3, 2 1s are 2, remainder is 1. Now in the reverse order, it's anyway 1 1, and you have to add 3 zeros, 1 2 3. What you have to do, you need to start with 2 power 0, 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. So anyway, this is 0, this is 0 into something, 0 into 4 is 0, 0 into 1 into 8, and 1 into 16. So 16 plus 8, 24. So we got 3 less than left shift 3, we got it as 24. Let's verify once again. So I'm writing here 3, I'm writing here 3. Let's save this and let's build it and let's run the code. You can see it's 24, it's working. Now we need to understand, sorry, this is actually 3 and 3, right? Now we need to understand right shift. So first what we'll do is to understand right shift. So I'll explain again 5 right shift 2. Now in this case you have to convert this to 5 to binary, it's 101. And right shift 2 means you need to remove these 2 and only 1 remains. You need to convert this to decimal. So 2 power 0, so 2 power 0 into 1, so that is 1. So 5 right shift 2 is 1. So you can also verify that 5, and just writing here 5 right shift 2, so 5 and right shift 2, and let's run the code. Let's save it and build it and run the code. You can see it is 1. So now coming back here, so I'll leave this. So we just learned about shift operators, and the last one, which is very, very important, is unary operators, and this we're going to learn in detail. Right, let's get started. So now unary operators, let's try to understand this. Now what I'll do is, to understand that, I'll leave this code module as 6.1. I'll create one more new empty file and save this, and I'll write here 6.unary unary operators example. And now what we'll do is, I'll just write include stdio.h, include conio.h, and as usual I used to tell you to write like this, so just write here author Meganadha Reddy, okay, and purpose to learn about unary operators. Now let's put the stars, and these are multi-line comments, you know it already. I'll write here void main, where program execution starts, and now what we'll do here is, we'll write here see here, now unary operators are like, we have 4. Now let me write in notepad. So now a plus plus, this is called post increment. A minus plus plus a is called pre-increment. A minus minus post decrement. Minus minus a pre-decrement. Let's try to understand this better, right? So I'll write here int a is equal to 5, int b. Now I'll write here b is equal to a plus plus. Now in this case, let me increase the font size. Be careful in this case. So this is called post increment. First the value of a will be assigned to b, then the value of a will be incremented. So first the value of a, whichever is 5, will be assigned to b. So b value is 5. After that, a value gets incremented, so a value becomes 6. Now this is called post increment. So printf a is equal to %ld, comma b is equal to %ld. Now let's try to put here a comma b. Now let's try to understand this. I'll just write here get ch. Now let's see once again. Now this operator is called post increment. First the value of a will get assigned to b, and then it gets incremented. That's why it's called post increment. So first a value gets assigned to b, so b value becomes 5, and then a value gets incremented, so a value becomes 6. So answer is 6 5. Now let's run this code. Now let's run the code. Now before we jump in and we see, so let's save it and build it. Now let's see if we get any errors. So we don't have any errors. Let's run the code. Now you can see here a is equal to 6 and b equal to 5. So this is called post increment. Now let's close this. Now when you write here plus plus a, so this is called pre-increment. So first value of a gets incremented, and then that will be assigned to b. So first value of a gets incremented, so a value becomes 6, and then a value becomes 6, and then that's assigned to b, so that also 6. So in this case we'll get the answer as 6 6. This is called pre-increment. Remember, in case of pre-increment and pre-decrement, both the values will be same. Pre-increment, first increments and then assigns. Pre-decrement, first decreases and then assigns. So in this case of plus plus, both the values are 5, both the values are 6. Let's run the code. You can see now I didn't build this, so let's build this. Now I just built it. Let's run the code. You can see the answer as 6 6. So pre-increment will first increase and then assign. Now what we'll do is, we will see post decrement. Now this is similar to post increment. So first value of a will be assigned to b. So b value is 5. and then a minus minus, so a value gets decremented, so a value is 4, so 4 5 is the answer. So let's save it and build it. So we are expecting answer as 4 5. Let's run the code. You can see 4 5. Now the last one is, we already said that this is minus minus a, that's called pre-decrement. First we have minus minus, then a, so pre-decrement. So a value first gets reduced to 4 and then it's assigned to b, so both values will be 4 4. Let's save it and build it and then run the code. You will see 4 4. So we just learned about different operators like increment, decrement, post-decrement operators, and believe me, this is very easy topic, which is normally students think that it's confusing, but it's very easy. Now the last one that we have operator is assignment operator, right? So assignment operator is used to assign the value, so you can simply write like this. Now let's declare it. Now you can see here a is equal to a plus 1. So here we're increasing a value by 1, so this is called assignment operator. We are assigning a plus 1 to a. So let's take you right, a is equal to 20. So you're assigning 20 to a, that's why equal to is called assignment operator. Now let's take, I want to increase a value by 5. I can write a is equal to a plus 5. Or I want to increase, I want to increase a value by 10. I can write a equal to a plus 10, and if I print it, printf %d comma a, %d comma a, so the value of a will be 15. So I can save it and build it and run the code. I can see it's 15. Now remember, the same line can also be written, I'll comment this line, and the same line can also be written as a plus equal to 10. That means increment a value with 10. So now also you'll get the same output as 15. So remember, a equal to a plus 10, a equal to a plus 10 is exactly same as a plus equal to 10. So now let's save it and build it and run the code. You'll see here exactly same. So similarly, a equal to a minus 10 is exactly same as a minus equal to 10. So in this case, the value of a will be minus 5. So let's save it and build it and run the code. You can see minus 5. Similarly, a equal to a star 10 is exactly equal to a star equal to 10. So a star equal to 10 is exactly same as a equal to a star 10. So in this case, a value will become 5 into 10, 50. So now I repeat once again, this is exactly same as a equal to a star 10. So normally the IT engineers, the software engineers who are new to programming will be more comfortable using this first approach, a equal to a plus a star 10. So who are new to programming, they're more comfortable, they'll be more comfortable with this. And who are like experts in programming or who have some experience in programming, they normally used to write like this. So a star equal to 10. Okay, so this is also called as assignment operator. In this case, the answer will be 50. Let's save it and build it and run the code. You will see 50. So we just learned about assignment operators. Now let's quickly summarize what we learned. So in this module, we learned about different operators. So we learned about arithmetic operators, and we learned the difference between division and modulo division. Relational operators, which will tell the relation between two operands. Logical operators, logical and, logical or, logical not. And bitwise operators, bitwise and, bitwise or, bitwise XOR. XOR stands for exclusive OR. And shift operators, this is left shift and right shift. And unary operators, which are like increment and decrement operators. So pre-increment, pre-decrement. So we have concept of pre-increment, pre-decrement, post-increment, post-decrement. And assignment operators, we have learned about equal to. This is exactly same as a plus equal to and a minus equal to. So we have learned the equivalent expressions for this. So hope this operator in C is very clear for you. And let's see what's the plan. So I'll just mark it as completed. And before I complete this, so I'm just marking it as completed. So in the next module of control structures, we will just start off with the different control structures we have. and how and where to use exactly which control structure, right? So before I close this, let me add these two code samples that I've used in the GitHub. So what I'll do now is upload files and click on this. And where is that? Let's go to D drive, my C programs, and I'll select these two now. So I'll select Unary operators example, learn operators.c, and again upload this Unary operators examples C. So let's upload two files. Okay, let me click on commit. And I have already told you how you can get these code samples, and you can get it from this URL, https://github.com/meganadha/c. So when you type this URL, you can download the code samples that I've typed in this module. Okay, so that's all for now, and see you in the next lecture where we will see control structures. Thank you.